Hello and welcome coders to the Sky Coding. So this is basically a second video of our tutorial series of Snowflake. So in this video we are going to see Snowflake architecture. Basically the Snowflake follows the two type of architectures. First one is shared disk architecture and the second one is shared nothing architecture. Basically it follows the hybrid type of architectures, and every architecture is having its own pros and cons. So we will discuss about these two architectures in this video. First one is shared disk and another one is shared nothing architecture. Okay, so let's move ahead without wasting any time. Okay, so this is the shared disk architecture. Okay, so for that let's move to the paint and let's understand that what is the shared disk architecture in depth. Okay, discuss the shared disk architecture here. Okay, with pen also. Here is a pen is also available so that we can better understand the shared disk architecture. So before going to the shared disk architecture, let's first understand that what is the architecture. So architecture, it is nothing, it's just tells the databases. Suppose that when the query is filed, okay, and how it is created by the underlying database and fetch the data and show it back to the client. Okay, so what happens as soon as the query is filed in the databases, and it triggers and goes to the clusters in that shared disk architecture in these clusters, and after that from these clusters the query, these clusters will take that request of the client of that query, and they will take the data whatever is needed by the client from this disk storage. Okay, so basically this is the main thing, that what is architecture and what architecture do. Okay, so this is a shared disk architecture, as the shared disk name is only suggesting that what is shared disk. So it is you can see this is a figure. Okay, so it is having only one disk storage. Okay, this is a disk storage, and there are three nodes, cluster node. This is a cluster node 1, and this is cluster node 2, and this is a cluster node 3. Okay, and these cluster nodes is having in their own CPU memory. You can see this cluster node is having one CPU memory, and this one is CPU memory, and this one is CPU memory. Okay, so every cluster is having their own CPU memory, and they are not sharing the CPU memory, but they are sharing their same disk storage. So this is a disk storage which is shared by all these three clusters. Okay, that's why this shared architecture is called as the shared disk architecture. Okay, so let's understand these things, and let's move to our points which is written on the right side. Okay, so it is written that used in the traditional database. Okay, so it is basically used by the every databases in these days. Okay, so this is a shared disk architecture, has one storage layer and accessible by all the cluster nodes, and this is having only one disk storage, and all the clusters are sharing the same disk storage. Okay, so let's take an example of one query. Okay, let's take an example of one scenario. Okay, suppose that any query is fired to the database. Okay, so suppose that there is a one student table, and the query is fired to insert the data in the student table. Okay, so we have given the command such as insert into table, and the table name, that is student. Okay, so we are inserting the data in the student table. Okay, so as soon as the query is fired by the client, okay, so then the query will be taken by these cluster nodes. Okay, so suppose that this cluster node has taken one query. Okay, so let's so guys follow this red color now. Okay, so suppose that whenever the query is fired by the client, okay, then suppose that this cluster node this three, this has taken request of that query, and it will now it will take the query, and now it will take the request of that query, and it will go to the disk storage, and it will log that tables. It is a, suppose that it is a student table in our case, so it will log that student table here, and it will insert that record in this table in the disk storage. Okay, so suppose that if the same time another query is also fired on the same table, then suppose that at the same time this cluster node 2 has taken the same query, has taken the another query of that table also. So this will also take the request of that query by the client, and it will again move to the disk storage, and it will see that the table is logged and the data is inserting by the cluster node 3, then it will not go here, and it will not do their work here. Okay, because the table is already logged and data is inserting through the disk storage, which is the request taken by the cluster node 3. So this cluster node 2 will not do their work, and it will have to wait in the queue. Okay, so performance comes into the picture. Okay, so the performance of the shared disk architecture will be low here, because at the same time when multiple queries are fired into the same table, then one query have to wait in the queue, and whenever another query is working there and the table is logged, so this cluster node 2 query will wait here in the queue. Okay, so this is basically a drawbacks of this shared disk architecture. Okay, so let's move toward the second point, that such as multiple cluster nodes having CPU and memory. As I have told you earlier, that there are multiple clusters and everyone is having their own CPU and memory, and these CPU and memory is not being shared. Only this disk storage is shared by all these three cluster nodes. Okay, and with the central processing layer and to get the data and process it. So this is the thing. Okay, and the third point says that any machine can read or write any portion of data into the central processing unit. Okay, so this is, I have told you earlier, suppose that a student inserting the records in the student table queries file. So this cluster node has taken that request from the client and it has given to the disk storage. It has gone to the disk storage and it has logged the table and inserted data in that table. Okay, by locking that table, and suppose that that request will be taken by this cluster node 1, then it will also go to the same disk storage and it will log the table and it will insert the record, but not at the same time, because uh, in this shared disk architecture every cluster is sharing only one disk storage. So that's why here multiple query processing is not possible. And suppose that if one query is processing there and table is locked, so the other clusters, other queries will have to wait in the queue. So here it is last point. Let's see the last point. It is saying that scalability and the performance are limitations. So this is basically the drawbacks of this shared disk architecture. I have told you the performance one, that how performance is limited here. I have told you earlier that one query, if multiple query processing is not possible here, as I have told you earlier, this performance is limit here, because suppose that one query is running, then other queries have to wait in the queue. Okay, so there the performance is limited here in the shared disk architecture. And let's talk about the scalability. So scalability means, suppose that I want to add one more cluster here. Okay, so now let's follow this purple color. Okay, so suppose that I want to add one cluster here. Okay, so suppose that I have added this cluster 4 here. Okay, so this is a cluster 4 and this is only one disk storage only. So suppose that if we are increasing the cluster, then we have to also increase the disk storage here. So we have to increase one disk storage here also. If we are increasing the cluster, then we have to increase the disk storage also. So this will be costless. So this is scalability is also not possible here. So this is that scalability is also limitless here. Okay, so these are the two drawbacks of this shared disk architecture. Okay, so this is all about the shared disk architecture. So now let's move to our second architecture, that is the shared nothing architecture. So this is basically the shared nothing architecture. Here you can see every cluster node is sharing their own disk storage. Every cluster node is having their own CPU memory and the disk storage as well. Is, you can say that this is okay. So let's move to our paint. Okay, and there we will understand better that what is cluster node by pen. Okay, so you can say this is a shared nothing architecture. As the name suggests, that shared nothing architecture means nothing is shared between the, no resources is shared. So that's why it is called the shared nothing architecture. So here you can see every cluster is having their own CPU memory and the disk storage as well. This, suppose that this is cluster node 1, this is cluster node 2, and this is cluster node 3. So cluster 1 is sharing their own CPU memory and disk storage. Cluster 2 is sharing their own memory and the CPU memory and the disk storage as well as cluster 3 also. So there is no resource sharing available in the shared disk architecture. Performance will be better here in comparison with the shared disk architecture, where there is only single storage device, and that single storage device is being shared by all the three clusters. Okay, so let's move to our points, which is written in the right side. Okay, so it is written as shared nothing architecture has distributed cluster nodes along with the disk storage, their own CPU and their memory. As I have told you earlier, that every cluster is having their own CPU memory, disk storage as well. So the performance will be better here in comparison with shared disk architecture. The advantage is here that the data can be partitioned and the stored across these cluster nodes, as each cluster node has its own disk storage as well. Okay, so as I have taken the example for inserting the record in the student table there in that shared disk architecture, so let's take the same scenario in this cluster Okay, so let's take the same example in this shared nothing architecture also. Okay, so suppose that I want to insert the record in the student table. Okay, so I have suppose that the query is fired insert into table, and that query, suppose that query is request is taken by the cluster node 3, then it will go to the disk storage and it will log that table and it will insert the records in that table. Okay, and at the same time, suppose that I have fired again the same query. Then suppose that this cluster node 2 has taken the query, and then it will go to the disk storage 2 and it will not wait in the queue here. It will do, suppose that this is for inserting the records, and suppose that there are some records earlier also. So suppose that some update queries were done and that is taken by cluster node 2, and then that cluster node 2 will take the request of that update query and it will go to the disk storage and it will update the record there. This cluster node 2 3 and 1, and there is a parallel processing is there. So multiple queries fired by the client and the multiple queries request will be taken by the cluster nodes, and they will go to the disk storage and they will do the updation insertion of whatever is needed by the client. At the same time here parallel processing is done, and suppose that I want to insert the record of I want to insert the address. Okay, so one address is Delhi, UP, or whatever. So that record will be stored in the, suppose that Delhi customer records is stored in the disk storage 1, and the UP customer records will be stored in the disk storage 2, and some other state records will be stored here. Okay, so the data is being shared. Okay, but the resources is not being shared in anytime any way. Okay, here so every cluster is having their own disk storage and the resources is not being shared here. Okay, so that's why it is written here that data is partitioned and stored across these cluster nodes. Okay, so all data is available, and whatever the multiple queries is filed, then that multiple queries will be processed at the same time here. Okay, so parallel processing is possible here in this shared nothing architecture. So let's move to our third point, that is each node in the cluster nodes. So each node in the cluster stores a portion of entire data set locally, which enables massive parallel processing. As I have told you, the state one example. So here Delhi customer records, here UP customer records, and here suppose that MP or whatever state record is inserted in, and suppose that multiple queries are filed from all these clusters, then they will move to their disk storage as well, and they will fetch the records from there and so that records to the client. Okay, at the same time and multiple processing is also possible here, as I have told you earlier. Okay, so this is all about the shared nothing architecture. So let's summarize and let's differentiate the shared nothing and the shared disk architecture. So the common difference between shared nothing and shared disk, in the shared architecture there we are having only single storage device disk storage, multiple clusters are sharing that single disk storage. Okay, so that's a common difference, and there the scalability and that performance is low in that shared architecture. Okay, and let's talk about the shared nothing architecture. So here every cluster is having their own disk storage, CPU memory. So here scalability and the performance is very high. Performance is very high, and suppose that if you let's talk about scalability. So suppose that I want to add one cluster, so we have to add one disk storage as well. Costing will be high, but performance is very good in this architecture. Okay, because multiple processing, parallel processing is available in this shared nothing architecture. So this is about the shared nothing architecture. So now let's move to our second topic, that is architecture layers. There are multiple architecture layers which are available to our Snowflake. Okay, so let's talk about one by one all these multiple architecture layers which are available to the users of the Snowflake. Okay, so let's you can see this is an example of Snowflake architecture layer. Okay, so Snowflake architecture layers is basically a three types. First one is storage layer, and the second one is compute layer, and the third one is the service layer. Okay, so let's talk from the bottom, that is the storage layer, and after we will see compute layer, and after that we will see the service layer. Okay, so let's see some of the overview. Okay, after that we will read these points and we will discuss that what is storage layer, what is compute, and what is service layer. Okay, so storage layer, as the name suggests, that what is storage layer, here the data will be stored here. Okay, so here physical memory is there, logical storage data is there. So basically in the storage layer data is stored, whether it is from the internal or whether it is from any cloud also. Suppose that here Amazon S3 or that one Microsoft Azure or GCP. So is in the storage layer, basically it is for storage. So here maybe the all things possible for from the clouds as well or from the local as well. Okay, so this is a storage layer, and after that compute layer comes. Compute layer here there are virtual warehouses will be there. Warehouses, it is a basically a big type of thing, as I have discussed earlier, that what is a warehouse, and their regional cache, local cache, and all these things will be available in this compute layer. And the last one is the service layer, where authentication and access control, infrastructure management, optimizer, metadata manager, and the security. This is the service layer where we are having suppose that we will create an account for the Snowflake, then we will see all these things: authentication, access control. There are multiple roles available in the Snowflake as well. Okay, so we will see all these things one by one. Okay, so let's first of all talk about the storage layer. So it is telling the storage is independent from compute. Okay, so storage, so independent means storage layer has no any connection with the compute layer. It is basically a independent from that compute layer. Okay, and it is a virtually unlimited storage capacity. It is having unlimited storage capacity. Okay, so it is telling that data is physically stored as a micro partition files. Okay, so data is stored here will be in the micro partition files. Okay, so let's micro partition files means they are the some of the immutable files, that is data cannot be modified once created and stored in the tabular format. Okay, in the columnar format or the tabular format. Okay, so suppose that every new data arrival creates a new micro partition. Okay, suppose that whenever we will insert some data, then it will create one new micro partition and it will store in that micro partition. Okay, so this is basically a micro partition files storage. Okay, each micro partition file is of 16 MB distilling, and every file gets replicated 3 times to ensure high availability. Replicated means it is basically a duplicacy. So here this is making the copies of every files 3 times to ensure the high availability and the performance. Okay, storage layer. Okay, and the file format is proprietary to Snowflake, and the file format this is CSV, PSV, TSV, or whatever the file format is there, that will be a proprietary of the Snowflake. Okay, and files are immutable, as I have told you in the micro partition, that files cannot be changed once it is inserted in the data in the tabular format. Okay, or the columnar format. Okay, and the table definition are logical or is and stored in the meta data layer. Okay, metadata layer. Table definition are logical and stored in the metadata layer. That definitions will be stored in that metadata layer. Suppose whenever you will create any table, then that data will be stored in that metadata layer only. So this is all about the storage layer. Okay, so let's move to our compute layer. Okay, so this is a compute layer. Okay, so compute layer is also called as a warehouse layer, where all the warehouses are available. Okay, the only way to access data from the storage layer, from the warehouses we can access data from the storage layer. Suppose that I want to access data which is available in the storage layer, so we will use the compute layer, virtual warehouse. So there are various warehouses which are available there. You can say access small warehouse, whatever you want. Okay, whenever you will see the interface of the Snowflake, whenever you will create the account of Snowflake, then there you will better understand that what is a warehouse and how to create a warehouse and what is storage layer, service layer, and all these things. Okay, so horizontally and vertically scalable, change the size of warehouse at runtime, add more nodes at the runtime. So you can change the size of the warehouse at a runtime as well. It is telling about that thing, and warehouse size vary from x small to the 4x large. Okay, so these are basically the sizes of the warehouses, which will I will discuss in the next slide, that what are the sizes and what are the pricing, what are the pricing of x small, x large. And here every warehouse works independently, and performance of one warehouse will not impact another warehouse. Suppose that one warehouse is extracting the data from the storage layer, and at the same time virtual warehouse 2 is also extracting the data at the same time. So these two are the different thing, and the performance of virtual warehouse 1 will not be affected by the virtual warehouse 2. So these two, where every warehouse is independent, okay, and will not impact another warehouse. Okay, so every warehouse have its own small storage which is used for the query data. Okay, so every warehouse is having some cache memory. You can you must be knowing about the cache memory. What is a cache? Suppose that you have installed any game in your mobile, so after installing that game there is some cache. Suppose that whenever you download something extra in that game, and then all those things will be stored in the cache memory, so that that data will be easily accessible at the, and the performance will not be low, and the performance will be very high. That's why the cache memory will be there. Okay, so there are basically two types of caches in that our Snowflake. First one is results cache and the local cache. Results cache will store the data, and suppose that whenever you fire the same query, then it will not move to the storage lane, and it will take the same data from that results cache only. Okay, so the performance will be better in this type of thing, in this type of scenario. Okay, whenever we use the cache one, that these topics will come in the or further videos. We will discuss there in the depth that what is results cache and what is local cache and how these works. Okay, and the last point is a compute can be auto suspended when idle, and these warehouses will be suspended, and you can resume those whenever you need it. When suppose that you are not accessing any data from the storage, then these warehouses will be auto suspended, and suppose that when you want to use this, then you can resume this compute data all as well. Okay, compute. Okay, so this is all about this compute layer virtual warehouses, and we will discuss that what is warehouse and how to create a warehouse and all these things whenever we will create account in our upcoming videos. So this is our last layer, that is a service layer. Okay, so service layer is a very important in our Snowflake. So service layer, it is, you can say it is a brain of the Snowflake. Here we are having the authentication and access control, infrastructure manager, optimizer, metadata manager, and the security. Let's talk about authentication and access control. These are two which are different terms. Okay, so authentication means, suppose when you do login, sign up, that is the authentication. Okay, so that authentication and login, sign up, password, and all these things are managed by the Snowflake, and there is a very high security in this authentication purpose. Okay, and access control, what is an access control? Access control means who can access that, means there, suppose that there is any asset, and who are the who else is having that permission to access that asset. Okay, so basically this is an access control. Here in our Snowflake we are having multiple roles, security admin only see, read, write, and which users can write, which users can read the data, which users admin, and all these things. We are having multiple roles in our Snowflake, so that is the access control. We are having authentication and access control in this service layer. Infrastructure management, infrastructure means, suppose that whenever we are using the Oracle one, then we have to install the software in our system, and we have to manage storage and all these things. But here Snowflake, it is a data cloud platform, so we don't have to install any software, and all these things, the storage and all these things will be managed by the Snowflake team only. Okay, you don't have to do anything manually. Okay, and this is the optimizer, which will do the optimization of the queries filed and all these things. This is a metadata manager. Metadata will store the cache and all these things. Suppose that it store the result cache. Suppose that when you fire this query earlier, and again you have fired the same query, then that same query will not move to the storage lane, it will move to the results cache, and it will take that data from there, and it will increase the performance as well of that Snowflake. Okay, and the second, security is also providing by the Snowflake. Okay, so let's talk about these points as I have discussed about these all 4-5 terms, and now let's see of some of the written points. Okay, so this is the brain of the Snowflake, and all the interaction with the Snowflake established via this layer. Okay, so whatever the interaction is made, so whatever the interaction is made between the compute layer, storage layer, so all things are managed by this service layer. It provides the service to all these two layers, storage layer, compute layer, and these things. Okay, so all the warehouses are managed by this service layer. Okay, by using these rules and the roles and authentication. Okay, it stores query output in the result cache. It stores the query in the service layer. This is a metadata manager in which we are having the results cache, which will store the query output. Okay, there are two types of cache, as I have told you earlier also, results cache and the local cache, which we will discuss in the upcoming videos about results cache and local cache. Okay, so Snowflake doesn't expose its service layer, and users can't get inside and access their metadata. Okay, So it is telling about these authentication and access control. We are having different roles here: admin role, security admin, reader or writer. There must be the business requirement that some users can only see the data, some users can edit the data, some is admin, some is security admin, all these things. Okay, so during the data load, service layer keeps track of which data is stored in which partition file. Okay, so suppose that some data is taken from the storage layer and some data is being stored in the stored layer. So all these things are managed by this service layer. Okay, maintain transaction consistency across the warehouse. The service layer is also maintaining the transactions, whatever the transactions happened in this warehouses, in these small warehouses or large warehouses, these all the things is managed by this service layer. You can suppose that if you want to compare this with the human body, so service layer is basically a brain of a human, and the storage layer is you can say is a stomach, and the compute layer is, you can say, these are the warehouse. So you can say it as a mouth or hands or these things, so they will do work. Okay, so service manager is basically a mind. Whatever the things, whatever the functions, whatever the user will do, all these things will be managed by the service layer only. So this is all about the service layer. So we have discussed about these three architecture layers. First, and the first one is storage layer, where data is stored and that data is processed, and the second one is compute layer, which will, there are having the warehouses which will access the data from the storage layer, and these warehouses are managed by this service layer. This is a service layer which provides the services to all these two layers: compute layer, service layer, and the storage layer. These all the three layers are available in our Snowflake architecture. Okay, so this is all about the architecture. And we have, so let's summarize fast what we have learned so far. We have discussed about two architectures. Okay, first one is shared architecture and the second one is shared nothing architecture. And the Snowflake follows the hybrid type of architecture, because every architecture is having their own advantages and disadvantages, as we have seen in shared nothing and shared architecture. Okay, and after that we have seen the architecture layer, service layer, compute layer, and the storage layer, and we have described in depth of these individual layers also. So that's it for today's session. Meet you soon in the next very interesting tutorial. And still, if you haven't subscribed my channel, so please subscribe us to not miss any of the updates of Snowflake series video. Okay, bye guys, take care of yourself.
How'd you get so far away?